Hello everyone. In this video, I'll be discussing about model evaluation and how to perform model evaluation using Python, accounting for unequal error cost using Python. So let's begin with what is model evaluation. So model evaluation in Python refers to the process of accessing the performance of a trained machine learning model. It helps determine how well the model performs on unseen data, which is test set, and can guide decision on whether the model is ready for deployment or requires improvement. Evaluation involves metrics that measures different aspects of a model's performance, such as accuracy, precision, recall, F1 score, and others, depending on the task, for example, classification or regression. So now we have how to perform model evaluation using Python. There are various steps involved. First is split the data set into training and testing sets. Second, train a machine learning model on the training set. Third is predict outcome of the test set. Fourth is use evaluation metrics to measure performance such as accuracy, precision, recall, F1 score, ROC for classification, mean squared error, MSE for regression. And here is the code for our model evaluation. And here is the explanation for the previous code in which we will import libraries such as load iris, which means loads the iris dataset as a well-defined dataset in machine learning. Second, we have is train test split, which splits the dataset into training and testing sets. Here it is. It will split the set into training and testing sets. Third, we have is random forest classifier. Here is the random forest classifier imported from sklearn assemble. So random forest classifier means it is used for model training basically. Fourth we have is accuracy score, classification report, confusion matrix. These matrices are used to evaluate models performance. Here we have imported them from sklearn matrix, accuracy score, classification report, confusion matrix. Then we have is splitting the data. In splitting the data, we split the data into 80% training and 20% testing. Here is the iris which we imported from sklearn dataset, and here is the train is splitting the data into training 80% and testing 20% set, in which we have xtrain, xtest, xtrain, y-test, y-train is equals to train test split, which is equals to xy, and test size is 0.2. And here we have taken random state is equals to 42, which ensures that the results are reproducible. And then we will use fit function that trains the model on the training set. Here is the fit function, which is used for fitting the data set into a proper format. Then we have the train modeling is used to predict the labels for the test data set X. Here it is. Then we will go to the accuracy score, which returns the proportion of the correctly predicted labels. Here is accuracy score, which is working on Y test and Y prediction. And then we will print accuracy in the form of a float. Then we have confusion matrix. So the confusion matrix shows the count of the true positives, true negatives, true false positives, and false negative. It is a 2 by 2 matrix that helps evaluate classifying models. And then we will print our output in the form of confusion matrix. And then we have random forest, which is used to provide an attribute feature importance that gives the importance of each features in making preparation. Okay, and then we will show our figure in the form of a heat map in which we have taken color blue, and then we will provide title as confusion matrix, and on the x plot or on the x side we will take predicted, on the y axis we will take actual, and which we will see on the final output, and then we will show them. And here is the feature importance in which we will represent them in the form of another plot or graph in which we have color taken sky blue. It will be represented by in the color of sky blue, and on the axis of that graph we have taken label as important score and y coordinate as features, and the title will be features important in a random forest, which we will see in the output. And here is the output for our code, which is accuracy is in 0. And here is the confusion matrix, which compares the actual value to the predicted value. And then here we have precision, which is equals to 1, 1 and 1 for Setosa and etc. Then recall value. Then we have F1 score, and then we have support. So now we have is accounting for unequal error cost using Python. So it is basically in machine learning, sometimes the cost of misclassification different classes is not equal. For example, in fraud detection, misclassifying a fraudulent transaction as non-fraudulent, false negative may be far more costly than misclassifying a legitimate transformation, such as false positive. This situation is also referred to as unequal error cost or asymmetric classification cost. To account for this unequal error cost, we can modify the training process or adjust the model's predictions based on the cost of associate with different types of errors. This is done through cost-sensitive learning, which alters the decision boundary of the classifier to maximize the cost of the misclassification rather than just maximizing accuracy. So here is the overview of unequal error cost in classification. And first we have is false positives, which means that the cost of prediction a positive class when the true class is negative. Second is false negative, which means the cost of prediction or predicting a negative class when the true class is positive. And then we have is the aim to minimize the cost of these errors based on how costly they are rather than just the number of errors. For example, false positives have a cost of 1 unit, false negative have a cost of 10 units. This means that the model should be more cautious about false negatives. It should reduce the false negatives even it means increasing the false positive. And here is the code for unequal error cost and classification, in which we start by importing the necessary library, which is sklearn from model and scborn for visualization. Here it is. And then we have is load the Irish dataset. Here it is Irish is equals to load Irish, in which we have taken x as Irish.data and y is equals to Irish.target, which has features 4 attributes and target has 3 classes. In this, the dataset is originally a 3-class classification problem. We simplify it is by converting into a binary classification problem. So it's a class 0 for Setosa and class 1 for all the other species. We do this illustrate how unequal errors cost can be applied in a simple context. In the real world, we should have different error costs for different classes and we should adjust the weight accordingly. And now in this code, we are splitting the data into train and test set. Xtrain, Xtext, Ytrain, Ytest, and the test size is 0.2. We split the data into training and testing set using the 80% for training set. Here is the training set and 20% for testing set, and here are the testing sets. Next we have a set class weight to account for unequal error cost. In this we have set class weights to account for unequal error cost, assuming misclassifying class 1 is 10 times more costly than misclassification. And here we have taken class weights at 0 is 1 and 1 10. So class weights are specified in this form, which means that error in class 1 are 10 times more costly than errors in class 0. And we then train the random forest model using these weights, introducing the model to more importance to correctly classifying class 1. And then we have is making predictions on the test set. Here is the predict function. And these predictions are made using the trained model and we evaluate the model using here at accuracy, which means the overall accuracy of the model. Here it is, we have taken printed accuracy in the form of float. And then we have printed confusion matrix, which means that how many positive, true positive, false positives, true negatives, and false negatives were classified. And then we have his classification. Here it is report is equals to classification under report, y test and y prediction. And then we have printed classification report, print report, which means that they includes precision recall and F1 score for the each class. And then we visualize and represent them in the form of a heat map of the confusion matrix to visualize the classifying performance. And here is the confusion matrix. which compares actual value to the predicted value. In this example, we can see the classifier has a lower number of false positives and false negative. And here is the classification report in the form of precision recall F1 score support. Since we give a higher weight to each class 1, this model tries to minimize false negatives for versicolor at the cost of potentially increase the false positives for setosa. So this was all about model evaluation. I hope you liked the video. Thank you.